Bismillahirrahmanirrahim. Assalamu alaikum viewers, welcome to my channel, and in today's video we'll try to find out the solution of the first order ordinary differential equations in such a way that if your ordinary differential equation is in a homogeneous form, how you're going to find out the solution of such kind of ODE. So one method is that we should reduce our homogeneous linear differential equation into a separable differential equation. Okay, so in order to learn how such kind of transformation, we should understand first what exactly your homogeneous function is. So when the homogeneous function will be cleared, right after that we approach to the homogeneous differential equation, and then we move on to its transformation into a separable form. Okay, so what exactly a homogeneous function is? So a function, presently we are over here discussing a bivariate function. Okay, the function involving two variables. So such function that can be expressed, or this function is definitely called a bivariate function. Okay, so a function is said to be homogeneous of degree n if it satisfies this condition. Like wherever I'm having my x and y variable involved in the function expression, I'm going to replace them with my tx and ty. So after solving, it should give me this format. So if the function is satisfying this condition, this important condition, then it is going to be declared as a homogeneous function of degree n. Okay, this is the degree. So in order to understand the concept, I have maintained a couple of examples here. Like for example, if I just say that my function f of xy is this, and now I ask you to analyze, is it a homogeneous function or not? And if it is, then what exactly the degree of this homogeneous function? So what I'm going to do, I'm going to replace my x by tx and y by ty. This way of checking, nothing more than that. So wherever I'm having x, I will put my tx. Wherever I'm having y, I will put ty there. Okay, so it is giving me a format like this. It comes out of the radical or square root, it gives me this form. Okay, so you can see that this is your f of x and your t is having power 1 there. So for my a's, let me just write down here, though it is not mentioned, but just for a's, and this is your f of xy. Okay, this is your f of xy. So I come to know that this is a homogeneous function of degree 1. Okay, so it is a linear homogeneous function. Alright, so this is the homogeneous function of degree 1. Alright, let's move to one more example. If I say that my function is of this type, so check it out, is it homogeneous or not? And if it is, what is going to be its degree? So once again, we are going to perform a testing. It's a beautiful testing strategy we got here. Wherever we have our x, we are going to replace it with our tx. Wherever we are having y, we'll replace with our ty. And there you go. Okay. Alright, so it gives us t power 10 x10 plus t power 10 y power 10 upon t square x square plus t square y square. So you can see in the numerator you're having t10 common coming outside, inside this is left, and in the denominator we are having t square common, so we just take it outside and we are having this thing inside left in the denominator. Then we cancel them out. What we are having is t power 8. Okay, so and the function is preserved over here, the bivariate function. So you can see that this is expressed as t power 8 f of xy. So this is also a homogeneous function of degree 8. All right, so that's how we do. So we move on to one more example, then we go ahead to the to those functions which are not homogeneous and how we are going to test it, and after that we approach to our topic. So it's a little bit I'm just trying to be a bit exhaustive in getting the concept, so I hope you just keep on watching with patience. So let's see one more example here. It's if your f of xy is sine of y by x. Okay, so let us check is it homogeneous or not. So we are going to replace thing like this. Okay, so this t and t gets cancelled. So you're having simply the same function back here, and no t is coming common outside. So you can write in this way that you're having t power 0. So you know that whatever the base is, if you're having power 0, that thing is 1. So it's like that. So t power 0 f of xy. So this is also a homogeneous function of degree 0. All right. So that's how you try to maintain here. So let's see one more example. It's not necessary that every time you're going to encounter a homogeneous function. So there are several non-homogeneous functions as well. So the same testing is going to help you in getting the idea that whether the function are homogeneous or not. So if you're having one more function, for example, sorry, it's like that, and y cubed plus 2xy upon x squared. Okay, this is also a very beautiful function, but is it a homogeneous function or not? Let us see. Let us perform the same check work. So wherever we are having y, we are going to substitute ty there, and wherever we are having x, we are going to put tx there. That's how we go. Okay, so it is giving us t cubed y cubed plus 2t square xy upon t square x squared. Now you see in the numerator t squared is coming common, so 1t will remain in this term. So okay, this t square will cancel this t square. So what is so left is ty squared plus 2xy upon x squared. Now you can see that it is not satisfying the condition of the homogeneousness. So like as it was said here, that this thing should give you a type like this. And over here, we are not having xy, f of xy. This is not f of xy because we are having t attached here. We cannot separate this thing out. So this function is not equals to your f of xy, okay? So therefore, this format is not satisfying this condition. Therefore, this function is a non-homogeneous function, okay? It's a non-homogeneous function. All right, so that's how we go. Now I hope the concept of homogeneous function is getting has now got clear, I hope, and I'm sure. So now let's move to the homogeneous differential equation. So if you're having a differential equation of such type, like for instance, if you're having a differential equation of such type, and over here this function is homogeneous function, then this differential equation is said to be a homogeneous differential equation of first order. Okay, you can see this is order 1 as well as the degree is 1. So first order, first degree ordinary differential equation it is. And presently we are discussing the types of the first order ODE, obviously. So this is the first order homogeneous ODE. Okay, so now what is the way of finding out the solution of such kind of equation? That's what the objective of this video is. So we are now going to learn how to reduce or how to transform this homogeneous linear ODE into separable equation. Okay, so over there we are going to analyze that wherever we are going to have definitely we are discussing the bivariate function here. So wherever we are having this variable, we are going to replace it with v times this variable. It's not necessary that every time you're going to have a function involving x and y only. It could be of a or b, it could be of s or r. So whatever the variable you're going to have here, you're going to replace this variable with v times this variable. Okay, so here y is going to be replaced with v times x. And after that, we are going to we are going to keep on moving, performing the preliminary mathematics, not the preliminary, the pre-calculus mathematics, and then we are going to solve this thing out. So you can see that wherever we are going to have our y conventionally, we are going to replace with our v of x. Okay, and then if we just differentiate both sides with respect to our x, okay, because we are going, every time you're going to differentiate with respect to the variable which is positioned over here. Okay, just keep this thing in your mind. So we are going to differentiate both sides of this equation with respect to this variable. Okay, and we are having x here, so that's why with respect to x, that's how we go. So okay, now we are going to apply u into v formula here. So it is v derivative x plus x derivative of our v. Okay, this thing simply gives us v here. It's not, I think it's, I've got some oil here, I hope. So it's, let me write here. So it is v plus x times dv by dx. Okay, so whatever the function you're going to have here, you're going to replace this variable with v times this variable, and you're going to replace this operator or this derivative by means of this thing. Okay, and then afterwards we are going to restore everything back. So let us move ahead to the one example. Okay, so here you go, a beautiful example here, and we are trying to solve this thing out. So let us check whether this function f of xy is homogeneous or not. So first of all, we are going to express this thing in the form of dy by dx. Something like this, and then we are going to switch this thing here and this operator, this differential over here. Okay, and this function, of course, this is your f of xy. Okay, we'll try to just check this thing, though it is quite visible that it is homogeneous equation of degree 1, but I must show it to you. So if I just say that if I just replace my x with t of x and y with t of y, it looks something like this, t of x dot ty. So it is tx square x square plus 3t square y square. Okay, my t is quite horrible. Alright, I hope you will compromise, but this is it. Okay, now in both, in the numerator we are having t square common. This is left hand side, and over here t square is here, and this is so left at this side. We just cancel this thing out, and we are having nothing left, so it is t power 0. I mean, we are simply having 1 left, so we express that 1 in the form of t power 0. And this is your f of x, of course. Okay, so I think I told you that this was the homogeneous function of degree 1, so I'm sorry for that. It's homogeneous equation of degree 0. Okay, so that's how we move on. All right, so this is homogeneous. And now we are going to reduce this homogeneous linear differential equation into a separable equation. So how we are going to transform it? We are going to replace our y with our vx, okay, because this was the variable written over here. So this variable will be equal to v times this variable, okay, and dy by dx is going to be replaced by v plus x times dv by dx. All right, so as we have shown already at the back, so no need to repeat that thing. All right, so now replace y with vx and replace dy by dx with v plus x times dv by dx. All right, so let's do it. V plus x times dv by dx over here, and this is your x square plus 3v square x square, the place of your y square, upon 2 times x dot vx. All right, so what is so left here? In the numerator we are having x square coming common, so we are having this thing left inside, and in the denominator we are having 2x square v. This x square and x square gets cancelled, so v plus x dv by dx is equal to 1 plus 3v square upon 2v. All right, now we are going to shift this v over here. So x dv by dx is equals to 1 plus 3v square upon 2v minus v. Then we perform some nice LCM work, so it becomes 1 plus 3v square minus 2v square upon 2v. So it gives us 1 plus v square upon 2v. So I can write it over here. So v square plus 1 upon 2v. All right. Now you see that this thing is equals to this. Now we have to perform a swapping work because this function is entirely expressed in terms of v. So we have to shift this whole v function involving variable v. We are going to shift this entire function over here at the along with the differential of v, and this x and dx will be shifted on the other side of equality. So it looks something like this after shifting. Okay, and this thing comes like this. That's how the variables are now separated. This homogeneous function entirely is now reduced into a separable equation. Now we will apply integrals at both sides to get rid from these differentials. So we integrate at both sides. And this integral, this v integral, can be handled by means of u substitution process. This integral will be handled directly. Okay, so over here, if I just replace this function with my u, I integrate both sides. I differentiate both sides with respect to my v. Okay, this thing is giving me 2v, and this dv will go over here. So 2v dv will be replaced by du. Okay, so it is 1 upon u du equals to this thing. Okay, that's how it looks like, and after integration it gives us ln of u plus some constant equals to ln of x plus some constant. Okay, I move this constant over here. Though I can do this constant work directly, but just trying to be a little bit explanatory. It's my habit. So this thing is again giving you some constant value, because obviously then two constant getting subtracted, they give you some constant answer, of course. So that's how this thing comes. And this constant is definitely going to be the log of some constant number. So you can express this constant number like this, okay, or you can replace it with the C4, C prime like that as well. It's your choice. Over here we're just going to apply the basic formula of the log, that log of a plus log of b give you log of ab. So log of x plus log of k, it gives me log of xk. Okay, so this ln, this and n can get cancelled, or if you can cancel them directly. Also, you just apply exponential function at both sides as well to show some beauty. So it's your choice. So over here we are having it's equals to x times k. Okay, we know that u was equals to v squared plus 1. Now we are moving back to the restoration. Okay, so this u was equals to what? It was equal to, let me show over here, the u was equals to v squared plus 1. So we are going to replace our u with v squared plus 1. Okay, and v squared was equal to what? We know that y was equals to vx. So v is equals to y upon x. So at the place of our v, we are going to write this thing. Okay, so it is, now we are having our, every time I put positive at the place of equality, I don't know in which world I'm moving. Okay, you guys can bring me back by just subscribing my channel. Okay, so alright, so what we have to do now, we have to find out the value of our k here. So now, as we have restored all our original variables, so now we are going to find out the value of this constant k by the help of these values. So y is equals to 6 when x equals to 2. That's what it means. So at the place of my x, I'm going to write my 2 here. At the place of my y, I will write my 6 here. Okay, and this 2 times k. Now let us solve this thing out. So 2k is equals to 36, and this is 4. Taking the LCM, we just got this thing, and I'm going to move this 2 over here. It becomes 8. So k is equals to 40 upon 8, and solving gives me 5. The value of k is 5 here. All right. Okay, so what next? We are now going to substitute the value of k over here. So y squared plus x squared upon x squared is equals to 5x. And we move this x squared here. Y squared is equal to 5x cubed minus x squared. Okay, and this is the solution. We can stop it over here, and also you can express it in the radical sign if you want to. So if we just take square root at both sides, we are having this answer, but we are going to use a positive value of x here because over there it was mentioned that the value was positive for y. Okay, so once when the x is positive, then we are going to have definitely y positive. So this is the solution of this homogeneous linear differential equation that we obtain after transforming it into a separable equation, or into a function of separating variables. Okay, so this is just the second type that we learn how to handle. After the first video of this series deals with solving the function of separating variables in ordinary first order differential equations. The second video is this that deals with the transformation of homogeneous linear ODE into separable equation. And we keep on moving till we cover this entire first order ODE types. and inshallah in the next video we'll try to cover those functions which are non-homogeneous, and if they are present in the differential equation, how we are going to reduce them into homogeneous form, and then we try to solve them out. So we are going to do that topic in the next video, so keep on watching. And if you haven't subscribed my channel yet, please subscribe it and hit on the bell icon to keep yourself updated with the latest good videos, informative videos, helpful videos. I'm just praising myself. So anyways, so don't forget to write your comments in the comment box below, and you can also see the email address and my Skype ID in the description box. You can contact me there as well for your personal queries. Take good care of yourself, and remember me in your prayers. It's the ending days of our Ramadan. Just pray for us. Allah Hafiz.